Hello everyone, myself Snehal Shinde, lecturer in Pravin Patil College of Diploma Engineering and Technology from Electrical Department. Subject is Utilization of Electrical Energy. Subject code is 22626. Unit 1 Illumination. In previous lecture we have studied the different types of definition of illumination. It is related to the illumination. So we have studied different types of illumination, and in this lecture we will study the laws of illumination. Basically, there are two types of laws of illumination. First is the law of inverse square, and second is the Lambert's cosine law. So there are the two laws. We will study one by one. First we will study about law of inverse square, that is inverse square law. So the statement of this law is the illumination of a surface is inversely proportional to the square of the distance between the surface and the light source, provided that the distance between the surface and the source is sufficiently large so that source can be regarded as a point source. So this is the statement of the inverse square law. And in this figure, illumination at a point, it is given as I divided by r square. Now, if a source of light which emits light equally in all directions be placed at the center of a hollow sphere, the light will fall uniformly on the inner surface of the sphere, that is, each square of the surface will receive the same amount of light if the sphere be replaced by one of the larger radius. The same total amount of light is spread over a larger area proportional to the square of the radius. The amount which falls upon any square of such a surface will therefore diminish as the radius increases and will be inversely proportional to the square of the distance. A similar relation holds if we have to deal with a beam of light in the form of a cone or pyramid. If we consider in this figure a parallel surface with cut the pyramid at different distance from the source, the areas of this surface are proportional to the square of this distance, and therefore the amount of light which falls on one unit of the area of this surface is inversely proportional to the square of the distance from the source. This relationship is referred 2 as the law of inverse squares, and mathematically it can be proved as, let us consider the surface area A1 and the surface area A2 at the distance R1 and R2 respectively. So in this figure we have considered the area A1, A2 and the distance between its R1 and R2. From the point source S of the luminance intensity I and the normal to the rays. So here from here to here the distance is R2. This is the R1 distance and this is the R2 distance from this point. Let the solid angle subtended be omega steradians. Luminous flux radiated per steradian is equal to I. Total luminous flux radiated equal to I omega lumens. Illumination on the surface of the area A1 is equal to I omega divided by A1 lumens per unit area, and the area A1 is given by omega R1 square. Therefore, the illumination on the surface of the area A1 is given by E1 equal to I omega divided by omega R1 square. We have to substitute the area A1 value into this. So, by cancellation we get illumination equal to I divided by R1 square lumens per unit area. Similarly, for illumination on the surface of the area A2 is E2 equal to I omega A2 is equal to I omega divided by omega R2 square, and finally we get I divided by R2 square lumens per unit area. So for this the illumination at any point can be calculated, that is luminous flux radiated per steradian to the distance between the plane area and the light source. So here is the law of inverse square law. Similarly, in this figure, this is the point source, this is the plane, 3 planes are given. Here is the distance d, again from here distance d, and between these 2 planes distance is d. From here 1d, 2d and 3d. So intensity is calculated that 1 divided by d square, that is the distance square. Again here is another figure. Here this is the point source, illuminance lux L, L by 4, L by 9. Area plane is given here 4a and 9a. So first distance is the d, second distance is the 2d from point source to the 4a. Next, from point source to the third plane the distance is 3d, that is the distance from source to the respective plane. So this is the similar figure. So this was the inverse square law of the illumination. Now next law, that is second law, is Lambert's cosine law of elimination. The statement of this law is that is according to this law, the elimination at any point on a surface is proportional to the cosine of the angle between the normal at that point and the direction of the luminous flux. So, the illumination at any point at E at any point on a surface is directly proportional to the cosine of the angle between the normal at that point and the line of the flux. Many times the illuminated surface is not normal to the direction of the light. So it makes an inclination angle as shown in line AB. So the area cover which the light is spread is then increased in the ratio, and illumination at point B is given as I divided by d square x into cos x. So this is the light source, this is the point A, this is the point B. The illumination from this light source to the point on the surface. This is the working plane given over here. Point A is here and point B is here. This is the light source, that is the I luminous intensity. The straight distance from the light source then to the point A is the straight distance, and it is given by h. Then the inclination angle is formed between the light source to the point B, as it is not over the top of the point B. So this distance, it is given as small d. Now this is the normal plane. So the angle theta, it is formed between this inclination angle to this angle. So this is the Lambert's cosine law, that is the illumination at any point on a surface is directly proportional to the cosine of the angle between the normal at that point and the line of flux. So here is the Lambert's cosine law. The angle cosine law is equal to E theta equal to E cos theta. From here, if the angle is 0 degree, okay. So here is the 100% illumination. As you take the angle, that is 30 degree, left hand side 60 degree, 85 degree, the illumination get reduced. See, 87%. As you changes the angle, so it get reduced. Similarly here, the 100%, if this is the source, here is the 100%, then this is the 50%, 60%, this is the 30%, this is the 87%, okay. So this is the angle made between the point source to the surface plane, okay. So this was the two laws of illumination, that is inverse square law and Lambert's cosine law. Thank you.